Okay, so this video is about analyzing why our loop system, human in the loop, is different than other AI builders currently on the market. So, namely Replit and Lovable, etc. So, basically, Lovable feels powerful. Replit feels powerful because they move fast. Loop is powerful because it doesn't break when things get real. So we are shipping what's truly production ready and not just what feels like it's production ready because the UI looks great. So the first thing is the technical blueprints versus the pretty demos. So um, we're going to use this kitchen analogy. So, well, actually, we'll start with explaining. Lovable and similar tools, they start with the user interface. They really optimize for that visual output. They create the illusion of progress. They build the cabinets before the plumbing, which we'll get to that, and it looks done until you try to actually use them. Loop, we actually start with the technical blueprints, putting things in the right places. So the designs, we design data flow, logic, and structure first. We lay the plumbing, electrical, and gas before the visuals, and the UI is the last step, not the first step. So it's like this. Let's just say you came to me and you said, Todd, I want you to build me a kitchen. And I say, okay, we'll build the kitchen. Um, and you give me your cabinets and your sink and your hardware and you say build the kitchen. I say okay, so I go ahead and remodel and I build out the kitchen. I call you up and you come back and you say, hey, this is great, but where's my fridge? Where am I supposed to put my stove and my dishwasher? And I'm like, hey, wait a minute, well, you never told me any of that up front. I only had the cabinet, so I put up the face. And you say, well, I'm telling you, there's no plumbing, there's no electrical, there's no gas for you to put these things in place because you didn't plan for that up front. That's kind of how those systems work versus how Loop works. We don't put up the drywall, make it look done, and then have to rip out the drywall to put the plumbing in and put the electrical in and put the gas in. We start with the foundation and then put everything on top in terms of the user interface. We make sure that it works and is production ready because something that's pretty and doesn't work is completely useless. Okay, the next thing is that we're going to have context window limits versus equals rather the junior engineer reset. So Lovable and Replit, etc., they only remember so much because of the limited context window limits. They hit those context limits pretty quickly. It forgets about the architectural decisions. It forgets about the past bugs. It forgets why things were done and where they were done. There's no documentation. Every session starts like a junior software engineer on day one. Loop, on the other hand, we document every decision and change automatically. We've programmed Loop to remember the architecture. We recall the fixes. We carry the context forward into the next session, and it never starts from zero. This is why Lovable feels smart at first, then slowly it feels like it's getting dumber as the projects grow. It just can't remember what you did before, but that's not the way that it's made, right? There's tunnel vision and it breaks the symptoms. And this is a critical pain point, right? So Lovable and Replit, et cetera, they can only see the file that they're working on. They make changes in isolation. They don't know what or how that change affects the rest of the system. So they don't know what's happening down the line when they're making a system change now. And it breaks dependencies silently, which is why you're going to wind up with all those Easter egg bugs that show up later in production when it's expensive to fix. And when I say Easter egg bugs, you don't know where they are. You just happen to stumble on them. And when you ask these systems, hey, where's the who did this? Why is this there? They don't know what they were actually working on. So we actually were testing this and it told us I don't know who did that. And we're like, well, hey, it's only you and me here. So, and I know I can do it. They don't know. They don't document and they can't see down the line. Loop, on the other hand, analyzes every system change system wide. We understand the downstream impact of every proposed change so that we don't create those Easter egg bugs. We prevent them in advance. We validate before implementing. We prevent breakage instead of reacting to it. That tunnel vision is why the demos work and the systems actually fail down the line. Okay, the next thing is AI is generally designed to be helpful, and that can actually be dangerous in terms of AI, right? It's kind of like it's got ADHD. It wants to be helpful. It goes off task. It fixes random things, optimizes things you didn't ask for. It does partial work, no documentation. Again, it's creating those Easter egg bugs. When the project becomes messed up before, and no one really knows why. Whereas with Loop, human in the loop, the agents are constrained to only the thing that they do. Each agent has one job. There's no wandering. There's no side quests. Everything is documented and nothing changes without the intent. Loop doesn't try to be helpful. It needs to be correct, right? Lovable and let's move to the next one. Lovable and Replit, et cetera. They have one AI versus 19 specialized AI agents. This is why Loop scales and the others don't. So with Lovable and Replit, et cetera, they have one AI brain doing everything. It does the design, the build, the testing, the debugging all at once, if it does the debugging at all. It's overloaded, it's inconsistent, and it's unreliable. Loop, we have 19 specialized AI agents. Each one does their exact thing extremely well. So we have certain agents that do, and we're going to call up some of that information right now. We have each agent that does one thing extremely well: architecture, build, QA, security, deployment. They're all separated. They work like a real engineering team. They're all in parallel execution, not in chaos. So as an example, and we've actually named all of these agents. Quinn does the requirements. It understands what you actually need. Scout does the research, finds the right tech stack for your use case. Charlie does the architecture, designs complete systems, not just the UI. Atlas, the builder, writes full stack code with tests. Ward does quality, secures or scores security, performance, and completeness. Maverick is the enforcer, rejects anything with placeholders or to-dos. Devin does debugging, fixes issues automatically. Clara does visual QA, validates UI, three different screen sizes, so mobile, iPad or tablet, and desktop. Octavia does deployment, committing to GitHub, and each is ready to deploy. And ultimately, this is where it really comes down to Lovable and Replit, et cetera. A lot of them are really just pretty wrappers on Claude Code CLI, right? They're selling convenience, they're selling the wrapping, but they're just upcharging the tokens on Claude Code CLI. So that might be pennies on Claude Code CLI, but they're charging dimes. And that's where they're making their money. They start the projects and you have to finish them. Whereas with Loop, full development operating system is what Loop is all about. It's orchestrated a full workflow, enforce standards. It has full memory. There's quality gates, GitHub delivery. It's finished deployable software all along the line. We're going to look at one other element in the technical section to make sure that we've covered everything in this video summary. Okay, so they're designed to hook users with fast, pretty demos. Lovable and Replit create the illusion of progress, get you a clickable prototype demo quickly, but they're going to fail at the system design, right? The interface on top of the Claude Code CLI. Let's see. Context window limits, tonal vision. We've got that. Uh, We're doing everything: discovery, requirements, proposal, agreement, blueprint, build, test, deploy, and deliver. We also do the multi-dimensional quality scoring. So security, 25%, which is important, 15% performance with load times, database queries, rapid AI development compliance, so no shortcuts, complete and implementation. That RAD compliance is at 25%. Code quality at 15% clean code and error handling. Visual quality at 20%, responsive design, accessibility, and it must meet a minimum 85 out of 100 to pass the test and move on. Lastly, we have what's called the recall loop. These other tools, every time you start a conversation with them, you're starting from zero. Again, that junior engineer. We have a recall loop. So we recall our project's architecture. We recall the bugs we fixed last week. We recall the system's coding patterns. We recall that one API quirk that took 3 hours to figure out. We recall everything that we've actually done in the project. It's a self-documenting, self-learning knowledge system that transforms AI from a forgetful junior developer into a domain expert that gets smarter each and every session. Last thing is the water cooler protocol. We have agents sharing with each other the valuable learnings that get promoted to a shared knowledge base. So Replit and Lovable and those types of systems have no such thing. We have a CSS gotcha that was discovered, for example, in Project A automatically helps projects B, C, and D. So like when you're at work and you're talking to your colleagues at the water cooler, um, like you're helping them, right? So those other systems, they learn and improve, or our system rather, our system Loop learns and improves on our specific projects. So, for example, ChatGPT and Claude, some of the capabilities, or they have the same capabilities, whether your first day or your 100th day. Your Copilot, it's autocomplete based on general patterns, not your patterns, and other builders start every time. So again, last thing with Loop MVP, you're going to get a full step application front end, back end database. You're not getting that with those others. User authentication and authorization, complete error handling, unit tests, integration tests, E2E tests, responsive design, API documentation, deployment configuration, and README files with setup instructions. That seems to be a good summary. Let's go.